In this tutorial, we're going to look at the creation of fire, specifically a fire on top of this torch object. The scene consists of a key light as well as the torch polygonal object. If I open up the torch object, I've also got an emitter represented by this disk or this face. I'm going to start by emitting particles from this emitter, and I'm also going to hide the emitter so it doesn't interfere with the simulation. To begin, with the emitter selected, I'll begin and create an emission, which sets up a point cloud. I'll call this the flame point cloud. And I'll open up the ice tree by pressing Alt-9. And if I open up the Show Hide Explorer in the ice tree, we can see that we've got the flame point cloud with an ice tree operator built in the simulation stack of the construction history. If I press play, I have particles emitting upwards in a very uninteresting manner. So our goal here is to increase the number of particles and also begin to give them a more interesting movement. So when it comes to the rate, I want to vary the rate by a turbulence factor. And if you look under the turbulized nodes, there's a turbulized compound under emission control called turbulized emitter value. And this allows us to take any emitter value, any value that's initialized, that's usually only set once, and animate that vary or vary it over time. I'm going to take a turbulized value, and I might want to be able to control the number of particles in my simulation at any time just to improve performance. So I'll multiply the results of my emitter value, so the minimum number and maximum number of particles, by a percentage, so I can kind of ramp it down. It's sort of like what we used to do in the old particle system. You'd have a on-screen display that you could just ramp up and down. To do that, I'm going to bring in a multiply by scalar, if I can spell it quickly or correctly. And I'm going to multiply that by a single scalar value. So if I look up under the constant math nodes, under the tools category, I'll find my constant scalar. And this will represent a percentage of these number of particles. So if I set my minimum number of particles to say between 10,000 and 20,000 particles, I can multiply that by this number here. So we'll start off with our percentage at 100%. So let's show 100% of the min-max values that we're using. I'll even right-click and create a comment here. So this is a percentage of the turbulized emitter value. Just zip that up a little bit. There we go. And I'll connect the percentage into the value and the emitter value into the factor, and I'll use that to control my rate. So now if I hit play, I get a very thick stream of particles being emitted. And I don't want real-time playback, I want to play all frames. There we go. Okay, so I've got a thick stream of particles. The next thing I'd want to do now, so if we just look at how this turbulizer works, the percentage factor, if I take that percentage factor down to say 10%, then we get 10% of min 10,000, max 20,000. So the next thing I'd look at doing is just controlling the age limit of my particles. And again, I'm going to use a turbulence to do that. So to begin, I'll start by bringing in an age limit compound, set particle age limit and delete particle at age limit. So we just need to do a filter for age, bring in the emission control, and execute that into the execute on emit port of the emit from surface compound. And of course, you always need to delete the particles at age limit, so we'll plug that into a port of the ice tree above the simulate particles node. So when it comes to setting the age limit, I'm going to make that a turbulence factor. So I'll use a turbulized value by range. So I look up the range category of compounds. There's our turbulized value by range. And anytime we need to create gaps between our particles, the easiest way to do that is to set the age limit minimum value, in this case, to a negative value so that particles don't ever get emitted. So we initialize them with a negative age limit so they never are birthed. So if I set the minimum age limit to -1 and the maximum age limit to say 3, we'll get some of these particles dying off a little earlier than others. So the height of the torch is a little too tall for my liking, so I'm going to have to find an age limit that works. And if I increase the animation speed, right away we start to get something that looks a bit more torch-like. So the real trick to the age limit is to make sure that you do have an animated effect so that you're pulling a turbulized range between -1 and 1 so that the particles do have a chance to change over time. So allow for animation, but at the same time control your animation speed so that the particles move in a fire-like manner. So what we really want to have here is we want to have lots of particles that break away and create separated chunks from the main emission. And if our animation speed is too low, the particles just seem to operate on almost like an EQ type of an effect. So I'm going to increase that speed until I get the chunks that I'm looking for. So I'm starting to almost get some chunks here. And I'm holding down Shift to fine-tune these values. If we decrease the turbulence scale, we increase the number of separated runs that these particles can make. And again, if I was to increase the animation speed from that point, we can add separated chunks to those increased number of separated runs. In my case, I think I'm going to want to increase the turbulence scale a little bit more. So I'll take the turbulence scale to about 2, which is a little bit much, but if I compensate by reducing the animation speed and fine-tuning both of them, I should be able to get something that works for me here. So I'll take the scale down a little bit more. And that's not looking too bad now. Okay, so I've got a good starting point. Let's continue on.